put the same casing. I hope you remember. Yes. Okay, you are going to plan different casings so that you use different mode weights to drill them. Is that clear? Yes. Now there's something I want you to look out for 1 minute before I'm going to show you. Now try to follow the bed from one end to the other. Okay? All through. And tell me if you're able to have a continuity. Okay? So if there's a pinch out somewhere, where can you see it? Okay, pinch out. Okay. Very good. You see that? So if you put your well, let's look at it carefully. There's a pinch out there. Continue. Last year there was something we saw. I want to be sure we can still maintain it. Come back a little. Good. Now let me show you something. It's not very obvious, but try to see. Do you see that unit that is above? You see? Do you see that that unit seems to pinch into this one here? Can you see it? So if you trace that very thick unit there, do you see it? Yes. It is pinching here. So my question to you is that if you drill a well here and you perforate it inside there, do you notice that it will not drain any oil that is here because it's pinched there? Do you understand? Yes. So somehow you need to put a what? What kind of well? A horizontal well, okay, to be able to touch them. So you look at this, you notice that we are talking of vertical compartmentalization, and we are talking of what? Lithological, lateral compartmentalization, which in this case is caused by pinching, okay, not by faulting. I hope that is clear. When you are going to pinching, okay, that's where your sand comes together and ends, okay. It can occur due to uncomfortable. Any question, because we leave here very quickly. To flow naturally for like 24 hours for 5 days. As that well is flowing, you check the pressure at which it's flowing. Based on that pressure, you can estimate from how far the fluid is coming. So that will give you the field permeability. It's not the permeability of just one place. It will tell you if the well is coming from far. And every SOC student here should know what I'm talking about, okay? Kufre, any idea of well test and well management? Do you remember something like that? That's why it's good we do it. I'm emphasizing it because well test will help you to have your field permeability. It will tell you the volume you're producing. It will confirm that your well is actually connected. And this is confirmation after drilling. It's no longer based on the economics we did before. Do you guys understand? In fact, after your well test, you revise the economics you did on your well, on your field, because you may discover it's more or less. When you do a well test, if the fluid is coming and you reach a fault zone, the rate at which the fluid is arriving will drop. Do you understand? If it's a channel, what we call radial flow, you will know. If it's linear flow, you will know. And that's the training I want to give you very quickly. Okay, there are curves that you see. And each of those curves tells you what you're seeing. And you link it to well economics if we have time, okay? So when we drill this, we drill horizontal well just because we are careful, okay? And one last thing I want to say, okay? If you're drilling this well, you are the geologist. The driller will be beside you. And while you are drilling, how will you know you have reached the competent layer? I'm drilling and I got to this. You see that very competent layer? How will you know? Who can tell me? Yes, an idea. What?
Reduction in
rate of penetration, which is known as ROP. So when you reach there, your ROP will drop. That's the language. Your ROP will drop, okay? And then when your ROP drops, you drill slow. When you enter the other one, it will become faster, and we call it fast break, okay? At that point where you transit between the hard rock and the soft rock, your torque may increase a little, okay? And then when you reach there, you are going to tell the driller, you may tell him, he may be a driller, no, you say, you may need to increase your WOB, which is your weight on beat. That's the thing they are using to drill. Are you beginning to understand? Your weight on beat, your rate of penetration, these are what, your torque, and many other things, standpipe pressure, okay? And many other properties. This is what we call drilling parameters. Is that okay? So tomorrow when you're going to do your
okay, don't mind the way it is. Imagine you are running the normal gamma log here. Okay. How would it be? And then let us know if we also log this, how would they compare? Okay. We log this physically the way it is.
Yeah. So if I have a paper, I want to just sketch maybe a small signal. So I see largely what I see mostly from what we have touched, a lot of sand here. But there are some bedding planes, and a bunch of bedding planes that potentially will be higher in the clay content. right? I don't want it's not shale, it's clay content here. So what the gamma ray measures is the resistivity, right? Radioactivity basically, which tells us, what based on the mineral content in the rock itself. So if I take from the top, let me assume that we have more. Let's just assume that what we have up there is a lot of clay, very clayey. We have a lot of sand here, but with some thin beds of clay unit or silty unit, So I'm going to have from this top, let's say I have a range that says this is sand, shale, or clay, right? And somewhere in between is the midpoint, right? So as I go deeper, I'm going to see more of my log is going to be telling me, okay, I'm doing something like this. And then at a point I see a boundary where I see a bit of sand, not a lot of clay. And then it tells me, okay, somewhere here I see it. So those boundaries where you have those bedding planes where we have a lot of clay will be more in this direction. Why these huge ones will be more sand. So the finer the grain size, it's going to be in this direction. And then the coarser it is, if I have very coarse sand or very sandy, blocky sand with no radioactive elements, no clay at all, it's going to be in this direction. So you're going to be seeing lots of things like this. And areas like this will be where you have those beds, those clay beds or clay rich beds. So it's stuff like that. Right.
That is not the outcrop log.
No, this is the gamma ray. Gamma ray.
Now, basically, you see, I'm going to somewhere.
Yeah.
The point I want to make, I want to draw the attention of the participants to one of the major uncertainties you have when you are handling subsurface data in the office. You are handling a powder sand, even though the tools don't show you. From your knowledge, hindsight, you know that
there's a little bit of clay circulation.
So you carry them along when you are making your projections, particularly when you are computing.
Yes, but there's a slight help we get in line with what you're saying. Yeah. That is why we're doing it. Is that while drilling, you don't depend just on the log. Yeah. You do your mud logging. And your mud logging is actual cutting. That is what you are coming to surface. But there's still a limitation. That's why I like what you're saying. Is that when this thing will come to surface, it will mix up. It will mix up the sand and the shale mud. So that's why when you do your cutting sample, you say 30% clay, 50% sand. Are you getting it? So you will notice that in your mud log, which is cutting coming to the surface, you have to calculate the lag time. The lag time is what distance does it take to get down and wash up. You are a geologist. You see the way I want you guys to be thinking. The real work, you need to think and do things. It's the geologist that does the mud logging. And so when it comes to the surface, every 10 meters within a reservoir, every 5 meters, you collect a sample and look at it under microscope. And you say it's 70% shade. Now what I want to say is that, like he's saying, in your electrical log or your nuclear logs, like gamma ray, you're going to have something like we come here, we go left, and it's all sand, which is telling you is wrong. Now in your cutting sample, it's going to be a transition. You will start gradually begin to enter the sand, And why is it a transition? It's not because it's truly a transition, it's because there's a mix-up. Okay, but as a geologist, when you have 70% sand, 30% shale, you now know it's this. You know that it does not mean it's mixed up. Do you understand the point? It's not really mixed up. It's just that you have intercalations of shale within sand. So you now see it in the field. Why is it important? Because when you want to complete your well, you know what's well completion?
Yes.
What is well completion? Somebody quickly.
After putting cement bonding,
after drilling, okay, yes, you make your well to start producing by perforating. So where this is important is that it's going to determine the kind of screen. We have SAS, we have standalone screens, we have different kind of screens. So it will determine the kind of screen you do. Whether you just perforate your casings or you put a screen, depending on the cleanliness of your sand. That's one. The second is sand treatment. There's a way it will be mud we begin to come into and block. That's when we do walkover. We come back to the well and we reduce the pressure. It will flow and push out all those mud. We leave it again. It start producing oil. The third thing you can do is your gravel pack behind. Do you understand?
Yes.
You will use different gravel pack depending. And in
sketch this thing.
okay?
Is that on the screen?
No, the screen is the equipment, the tube with holes.
Yes.
That's the screen. But gravel pack is what you put behind that casing. Okay. Do you understand? And when you finish, you can do acid treatment. Okay, there are things you do to dissolve some of these things to allow your fluid to flow. Okay, so that's a very uncertainty. You notice we are not even discussing it, but it's the highest problem.
Yeah,
but it's detailed.
We're going to show this. So on the seismic data you see with all those peaks and troughs, what we are able to map is this as maybe the top of our reservoir and this peak as the base. But in reality, each of these wavelengths, each of this cycle, in terms of resolution, from the seismic to the well, this is about 20 meters. So we're calling this the top of our sand, but on the well, we know that it's one cycle of this peak and trough is about 20 meters. Okay. And then if you go from the well, that's why we rely heavily on core and then mod log. What the core have seen, you actually look at the core interpretation and then the mod log. But again, the challenge with that is you are looking at a field that is, in terms of GD, it's huge, but the log is just about how many centimeter radius, and you're trying to use that to make a prediction for a field that is how many,
and that's where
kilometers. Exactly.
So since reservoirs are hard to detect the top and bottom,
you can't see that.
But well test is the last thing that helps you to say, is my food really coming the way I thought it will come? At what pressure is it coming? And that guides you on your well completion. Okay.
So